Welcome everybody to the September Drake's Lounge 2024. Uh, some announcements. Remember, there is we're doing the 2025 membership renewals. Currently, right now, on our database, we have 680 subscribed members, but 402 of them have not upped their membership for 2025. So, the way Tom Jacobs and I are probably going to handle this is that we're going to wait till January 1st, 2025, and then turn off the memberships for the people who haven't updated their 2025 membership and et cetera. Okay, so we will send out a couple more notices before then. But right now we have 402 members who were not renewing. A lot of that has to do with they're not they haven't renewed since 2020. Some of them haven't been renewed since 2020. So we still need to clean up our roles a little bit. So we don't really have 680 members, but there's a lot of people that can renew the 2025. Okay, so that's all I've got. Any of the officers or board members have anything that they want to say? All right. And so, Ted, let's start with you.
You mean like news? I'm afraid I don't really have any news. I'm
Any
working on
update?
a three. I'm working on a three antenna interferometer, and I'm working on an all sky camera, but that's optical. And I'm working on solar scope, but that's optical. So I'm distributed. uh, no great big news. No
How about
results.
didn't you put in a new capability in EZRA?
I don't know. I'm putting them in all the time. Sometimes I get around to posting them. I think I should test them a little bit, and then I keep finding oops and fix those bugs.
Okay.
Was there a
Um,
new feature I'm supposed to remember?
well, you just told Rob Lucas that there's a current way to enter the elevation that's more graphical, I guess.
Well, I keep updating Ezra every so often. I am not so bold as to post it on the forum, so you got to go look.
Okay. One other notice: we did get questioned by the AAVSO group, which is the uh, Amateur Astronomical Variable Star Observers. They are disbanding their Solar SID observer program, and they wanted to know if we could take it over. I checked with the board, and the board is not going to take over their part of it because we have a very dynamic super SID program ourselves. We do as the Stanford. So they are going to send over their observers, and we're going to probably get a couple more members and some more super SID activity because now we're sort of absorbing the AAVSO group. So just watch for that. You'll see a bunch of new people that maybe are more super SID related. I was a member of that for 6 years. I did a lot of observations and reports, but they're just running out of steam, etc. on that. So we now have it, but we're not going to do anything different. We're just going to get more members. Okay, let's go across the pond let's go Robert Lucas. He's the farthest time zone person.
Well, I'm like Ted, but I'm getting ready to go off to Cochrane, Chile, in the Andes in next week for an annular solar eclipse, and that's optical. And trying to figure out what to do with the radio telescope while I'm off doing that. So basically, nothing new to report except learning a lot.
Great, great, and we'll take optical reports. So I'm not too I'm not proud. Okay, Wolfgang.
Yeah, I think the best thing I could do is to hand over to Vanessa. She will be able to tell what we are doing with our interferometer. Maybe she has some things she can tell.
Go ahead, Vanessa.
Yes, I can share a few slides. So we are still working on a 3-element interferometer, and we had some curious effects because we changed the baselines a little bit. So the middle antenna is made mobile, so we had long baselines of apparently 58 meters, and then we needed to change the cables because they were too short. And then we had a not so nice effect because apparently when the sun appears, the signal drops. At first we were a little bit curious and didn't know why we had this effect. Also, when we observed at other days, you can see in the morning that the signal still rises as normal on the middle antenna, like on the east and on the west antenna. But then in the afternoon it drops, also below the level of nighttime observations, which is not usual. So we did some cable measurements, and we measured the attenuation of the cable, and the cable was outside of the garage. So at nighttime, the temperature dropped, and so the attenuation got less, and on daytimes we had more attenuation and it was hotter outside. And here you can see a graph over 1, 2, 3, 4, 5 days where we measured the attenuation of the cables. So as a second test, we did the same with a much shorter cable, and there you can see some fluctuations, but not as much as for the 60-meter cables because it was almost 1 dB, so quite high. So what we did next is that we took the 60-meter cable inside, so there shouldn't be that much temperature fluctuations over the day, and you can still see some minor fluctuations during night and day, but it's much less than before when the cable was outside. So our idea now is that the attenuation depends on the temperature. And what I did next is that I applied a baseline fit to the nighttime. So then I had an idea on how negative the signal gets when it is during daytime when we observe the sun. And then I tried to match it with temperature measurements and humidity. Apparently our weather station is down, so I had to work with data from another weather station, which is not nearby. It's a little bit further away, but at some points one can see that if we have a low temperature, then apparently our attenuation is gone. But if we have high attenuation then we also have a high temperature outside. It doesn't match quite well, but at some points it does match. And also here the case is that I'm not sure how much the temperature weather station is comparable to the temperature that we have at our observatory. And that's our issue with the cables. And what I also been working on is that we measure the correlation, the real and the imaginary part. And then you can calculate the visibility amplitude and the phase of the visibility. And if you put that on the so-called UV map, then you have certain information about the visibility of the sun, and then you can apply an inverse Fourier transform to get an image of the sun. So basically this is the sun, which we were measuring with the long baselines. And if you do the same with shorter baselines, we went back to the shorter baselines last week. And this is, for example, a measurement from yesterday. So here, again, the correlation, real part and imaginary part. And here, what you can see here is a minor solar flare. It's not comparable to the ones we had in May, but it's still there. And then again, the same stuff, amplitude of the complex visibility and the phase. And you can also see the flare in the visibility and a little bit in the phase, although in the phase, since it is almost at the end of the solar observation, it's not very accurate. As you can see in the morning, we also have some effects in the phase since the sun is not in the full beam yet. And again, you can create an image, but now you can see that you don't have the whole sun in the image because your resolution is not good enough with the shorter baselines. Yeah, that's the stuff I've been working on and we've been working on with Wolfgang together.
I'm
I've got
thinking
two
this is the
questions,
first.
Vanessa. Oh, go ahead. Who's?
I'm thinking this is the first example we have of imaging. This is exciting.
Well, that's
Well,
what that was.
actually, there has been some very nice work by one of our members. I'm trying to recall the name who did it with, I believe, a set of 3-meter dishes, which he put at different baselines and then generated an image of Cygnus A. I found this very fascinating. That unfortunately, I don't recall the name. He doesn't typically participate in the chat here, but maybe somebody else remembers. Rich, do you remember the name? It's been a couple of years ago, and in one of my presentations on the SARA, one of the SARA conferences, I mentioned that. But anyway, I mean, it's very nice that we, in this case, with very simple means like three-element interferometer consisting of 3 stovepipes, we can create an image of the sun with an interferometric image of the sun. The other message that I find kind of interesting is that for long cable runs, like the 60-meter that we had, you really want to be careful about the temperature fluctuations of the cable. It is known that phase shift in the cable does occur with temperature, but it also seems that there's more amplitude or more attenuation variation of the cable with temperature than I had expected. So we're doing a couple of more experiments, like using a different cable type and so on, repeating the same experiment to see what is really going on, whether that's a specific characteristic of that type of cable or maybe even that specific length of cable. But anyway, it teaches us a story that you want to be careful with long cable runs and their characteristics.
You'll probably get
one
comment.
better. You'll get some sun effects too. If it's cloudy, the effects won't be as much as when it's sunny. You're really going to get some heating on the black coax that's even beyond the ambient temperature.
Yes, definitely. I mean, we had a couple of sunny days where the cable was lying outside and it's a black coating, so it certainly did heat up. There's one thing, maybe Vanessa, if you can go back to the multiple day thing. Yeah, that one. That's something that we're still trying to understand. What you see during daytime, not only that the attenuation gets higher, so the signal drops, but you also see strong fluctuations. And we don't think that that is a purely effect that the temperature goes up and down. Of course, there are fluctuations with the sun intensity. This might be, but that's speculation at this point in time, that we have a little bit of reflection at the ends, and as the cable varies its delay, we get sort of slight fringe patterns. But that's something that we're trying to find out with more experiments. So that it might not be just attenuation, it might be reflections creating fringes.
As the cable changes its delay, is that because of temperature?
Yes, that's a known effect. I mean, cables do, the delay over the cable does change with temperature because of the expansion and maybe an influence on the dielectric medium. That's a known effect. And what I did find, though, is that there's hardly any literature on the attenuation change of coaxial cables with temperature. I found one from an Italian guy, but there was a different cable. Unfortunately, we don't have a climate chamber. I would really love to put that into a climate chamber and really do a very controlled experiment, but well, we don't have that.
I would suggest putting out maybe a couple feet of coax, pull out the center conductor and put a thermocouple in there and set it next to the wire. You'll get a better characterization of the cable doing it that way than either measuring the surface temperature or certainly the ambient temperature. And you're going to be changing the diameter of the wire. And over that length, you're going to be changing impedances. And so you certainly can have, I mean, that's a long run. So you certainly could have some temperature effects when you're looking at down at fractions of dB. That's possible. I think a good indicator would be to make something that's that characterizes the actual internal temperature of the cable and see if you get better correlation that way.
Yeah, of course it's a long run, and being exposed to different parts of the area. We definitely know it is a temperature effect because if we put it inside, we get a much more stable. At the moment, the plan is also to measure a cable which essentially is buried, so it's really temperature stable. We'll do a similar experiment there. We'll also try different cable types. Anyway, that's sort of a side effect and a side finding from the interferometer experiments, where we had essentially we started having a long cable run, looking into some funny effects and then trying to understand those. So that's where we are. And the message, as I said, is long cable runs can bring you interesting things.
So, Vanessa, I do have a question. If you go down to your fringe pattern and then your, what is the software you're using to convert it from a fringe pattern to an image?
I do it with Python and then an inverse Fourier transform, fast Fourier transform. It's something I did on my own. It's not some preprint software.
Oh, have you written that up at all? That'd be really good to know how to do that, because that, I think, I've never seen that done at this at the amateur level.
Yeah. I still might do a few more tests, but in the end, I can definitely do something. Yeah. I
think that'd be great. We can maybe put that in TED software, and we can start imaging with TED software. There we go.
Well, yeah. It does. Of course, it does take first of creating the data, the interferometric data. So the raw data essentially is IQ, which is then correlated. So there's quite something behind it. Definitely, it will eventually be written up in Vanessa's master thesis, which is scheduled to be done March, I guess, Vanessa, right?
Yeah, end of March, yes.
End of March next year, and then of course there will be a master thesis, and we'll see how can we provide all this stuff.
I'd like to say I think you're doing a nice job, Vanessa, putting all these graphs together and collecting all this information. And I know that you probably thought you were going to get good data right away and maybe get some good science right from the readings, but instead you have these issues to deal with, and you're having to dig through those and understand them, and all that is important, and a nice job and effort to get this all done.
Thank you very much.
All right, any more questions for Vanessa or Wolfgang? Well, excellent work. Can't wait to hear your next update.
Yeah, sure.
Okay, let's see. Andrew.
Oh, hello.
Hello.
All right, okay. Yeah, I was quite enjoying that talk. Yeah, fantastic. Gosh, it's all above my head, Wolfgang. But I've got a couple of questions, but I hope Wolfgang doesn't mind if I send them to him separate, because they're a little bit basic. Right, so I've had a wonderful weekend, actually, because I think you mentioned the last meeting that we had. I'd had a knee replacement surgery, which has gone very well, but I've been suffering a lot of pain with it. And only the last few days, it's got a lot better, which is marvelous. And it fits in with the fact that yesterday I was the first speaker at the International Astronomy Show in Coventry in the UK. I found myself talking for an hour to a packed audience, amazing, with people saying they'd come and stayed overnight, which amazed me. To hear me tell them how to map the Milky Way in the hydrogen line by radio, how to weigh the Milky Way and demonstrate the smoking gun for dark matter. And then had a very tiring day the rest of the day because I kept getting interrupted by people who wanted to ask me further questions as the day went on. And people wanted to send me them stuff. So it was great, actually. The British Astronomical Association Radio Astronomy Group had a stand, and they told me that after the lecture, they were inundated. They certainly were full of people all day speaking to them, which was marvelous. So what I want to say is that there is a real appetite out there amongst people who are not your traditional radio astronomy group. They don't have any engineering background or telecommunications background. They're not radio hams. But particularly in a place like the UK, where we have a serious cloud problem with global warming, very serious cloud problem. People are interested in something a bit different, which works in spite of the cloud and perhaps helps to expand their astronomy participation at not too much cost. So I was able to tell them about the new software-defined radios and how these new bits of kit were changing the whole situation remarkably. And of course, I had a wonderful opportunity to sell Ted's Easy Radio Astronomy Suite big time. So I think he's going to find there's a lot of downloads coming as a result of that, which is marvelous. So fantastic stuff. A lot of people out there who are really quite interested in that. The other bit of news I've got is that last week somebody put, forgive me, whoever it is online here who did this, I'm a horror with names, but somebody put a message on the SARA mailing list about these solar heaters, which look suspiciously like satellite dishes with a reflective surface on the inside, where the idea is you stick it up pointing at the sun and then get your, I don't know, your kettle or whatever and hang it at prime focus and it heats it up for you. And people were saying, oh gosh, these are quite cheap on eBay in America. Well, we don't normally have those on eBay here in the UK, at least not so cheap. But I happened to look at that, and lo and behold, somebody was selling one secondhand for £50. So tomorrow, it'll winding its way to my house will be a 1.5 meter, 25 kilogram lump of steel, which will be a satellite dish, effectively. And I could do with some kind soul telling me how I make a feed now to pick up hydrogen and aim it at said dish, and also to tell me whether I need to do something to get rid of that solar reflective surface before I accidentally point it at the sun and burn out my feed during the day. I would just say, and God bless his soul, because he's absolutely right, Alex has quite rightly said to me, I should finish one project before I do the next. And he's quite right, but hey, that's not half the fun. And when you can find it for £50 in the UK, you pick it up while it's available. I still have to explain to my wife why 25 kilograms of steel are going to turn up at the house, because she's not going to be a happy lady. But there we are. Thank you very much.
A question, Andrew.
Yeah, by all means. You can criticize as well. I don't mind.
Yeah, by the way, I agree. We've got to take that reflective surface off. You may or may not know that I operate the scope in the box logistics over here. And from the enthusiasm for hydrogen you saw, might I suggest we try to figure out how you can do a scope in the box through Amazon UK?
I've done it.
You've done it, but can you make it so that UK participants can order through you or the way they order through me? Or just give them the part numbers and let them order themselves.
Well, that's what I've been doing, Les. If you can Oh, is there any chance you can send me your email address and I will send you the list of components that I've been sending out to people?
Yeah.
Scope in the box program that got me all excited and interested in this in the first place. I think it's absolutely brilliant. And what is incredible about it more than anything else is that there's so much that's incredible about it. But so this is not to do down everything else. But the thing that really stands out to me is how remarkably good the manual is. It's a very, very, very well written, especially for people who don't know what they're doing. I can only congratulate you for all that you've done.
I will point out that I'm just the guy that does the logistics. And the manual and the software are all out there in the Sarah community, but the easy software seems to be working very nicely with it.
It does. That's what I use. Mind you, having said that, SDR Sharp with the IF average also works very well with it as well. So a couple of options for whatever people want to do.
Precisely. But the point is, to follow up on what you said at that meeting, this is the hook to get them online if you can figure out how to get that hardware in your users on the UK side.
Yeah. Well, this is the second talk I've done this year. The first one I did was at Astrofest, which is a bigger conference in London in February, and that was on muon detectors. It's quite interesting that I've been picked up twice in a year to do talks on radio astronomy.
Well, let's get Scope in the Box UK going, and that's my nag out.
Yep, we'll get it sorted.
Okay, great. And Lester, call me on the phone. Anyway, maybe I've got any questions for Andrew. Great work, and why don't you print off some brochures and stuff? We can reimburse you, or some things you can hand out on your next talk that get people to join Sarah.
Oh, that's a good idea. Yeah, that's a very good idea. And I need to get a T-shirt done so that I can have a Sarah T-shirt as well when I stand up.
Also, that's another good thing to note. Ken Redcap and Wayne McCain are the Western Conference coordinators for the for next year for the Western Conference. Currently, right now, it looks like the VLA in March. So that's tentative right now. Well, we should have more information. He's just right now he's negotiating with some hotels and things like that. So it's not 100%, but it's like 98%. So for VLA in March, no, don't know the exact date yet. So that's where we're going with that. Let's see, Dimitri.
Quick question. Is that the VLA in Socorro, New Mexico?
Yes.
Oh, been there before. Okay, thank you.
Okay.
Hello to all. Thanks, Rich. I will be short. Internet and drop. I continue observations with my new dish, with my new telescope, 6.7 gigahertz. This is strongest maser in the galaxy. Top first in Edward list of brightest 6.7 masers. This is data from I met Japanese facilities, 32 meters dish for this maser, about 4,000, 6,000 Yansky larger, higher line, two lines, higher line up to 6,000 Yansky, small line 1,000 Yansky. this maser is located in southern hemisphere, not far from galaxy center. This is the strongest maser in the galaxy. In Moscow, it is seen up to 14 degrees in elevation. It's not too high. The sky. This is my new. I never seen this matter before, because in my old location had problems with southern directions, low elevation and southern direction, but in the new dish is hasn't such problems. Sergei Zhutyaev dish designed for millimeter wave 2.4 meter. And this result up to small, up to 4,000 Yansky bit line, and about 600 Yansky small line, 1 hour of integrations. Not beginning of this September. Maybe levels, my levels, some underestimated. This measure is rather stable, and I can compare levels with Japanese data. Maybe my levels some underestimated. This spectrum was obtained at the beginning of September. Thanks, that's all.
Any questions for Dmitry? Thanks.
Dmitry, do you have a plot maybe of your observation?
No, please again.
Do you maybe have a plot? A graph?
This is internet problems. I didn't
Oh,
really
no worries.
possible. Maybe in chat I try to answer. Edward, thanks for questions.
Okay.
Okay.
Thank you. Edward, since you're on, what do you got going on?
Not so much in terms of radio astronomy. Actually, we finally had some pretty decent weather in the last.
Can you get closer to your mic, please?
Oh yeah, sorry, yeah. Can you hear me now?
You're still a little weak, but go ahead.
Okay, well, I'll try. Yeah, actually, we had some quite nice weather, so I haven't really done much radio astronomy. I was just very busy with optical astronomy projects. So I don't have much to share. Maybe one thing, actually. I did an observation of Westerau 3 at 12.2 gigahertz. Yeah, that may be worth sharing. All right, can you see? Great. So yeah, this is a methanol maser at 12.2 gigahertz. It has an intensity of about 800 Jansky. So it's fairly strong. Actually, I recently got one of those bullseye LMBs. So these are basically regular LMBs, but they have a TXTO, a temperature compensated crystal oscillator. So they don't drift as much in frequency with temperature. At least that's the idea. And they claim that they have a stability of about 10 kilohertz. And I was thinking like, oh, this might be actually nice for someone who would be trying like this project doing metanomases, but who doesn't have the technical skills to actually like break open an LNB and replace the crystal oscillator with an external signal. It's quite tricky to do that. So I wanted to test whether this would work well. And well, actually it worked quite well. So this 3-hour integration. Yeah, the signal to noise ratio is about what you would expect. There was, however, a small, about 0.5, maybe 1 kilometer per second shift in the spectrum with respect to the literature values. So apparently it's not completely stable. So there's still some minor frequency deviation of about 20 kilohertz. But yeah, I think this this was just a neat little test to see how this would work. So yeah, this was really my only observation that I've done really in the past 2 months or so. Any questions?
You said you're using a different and new LNB for that purpose, which has the TXO, right?
Yes.
And compared to the previous one, that was not coupled to any reference. It was a free running oscillator. Is that correct?
That also had a crystal oscillator, but it was not temperature compensated. So it was fairly stable. So I would see about 10, maybe 20 kilohertz shift sometimes during long observation runs, but not more than that. But there were sometimes shifts of up to 100 kilohertz between different observations, between different days. So not sure why that was, but that's quite tricky. So if you're trying to compare observations from different days, then you have to take that into account. And I had to like basically do a calibration on a stable reference signal every time I did an observation.
Okay, but there's no direct possibility of injecting a reference signal to.
There is the possibility to do that, but it would require some pretty serious how do you call that? You have to open the LNB basically and get out the oscillator and inject somehow the reference signal. Definitely possible, but it's not easy.
Okay.
I can suggest an alternative. If you can generate a signal that is locked from a signal generator locked to GPS or something, you can put a weak injection of that up at your dish into the LNB so that when you process the data, you've got a known reference to fiddle the data against. But that requires the ability to generate a stable signal at that frequency.
Yes, that's actually how I do it at 22 gigahertz, where I just have an LNB with a free running oscillator. And I'm indeed using a weak stable reference signal that I'm injecting at the dish to shift each individual spectrum in the post-processing to correct the frequency. But yeah, I basically the idea behind this test was like, okay, would a person who doesn't have like the necessary technical skills to do these sorts of things, to generate a very high frequency reference signal or to inject a stable reference signal, would someone be able to do this type of observation using just off-the-shelf equipment.
Do you know the crystal frequency of that TCXO?
Ooh, not off the top of my head. I would have to go back into the specs of that.
A wild guess as to roughly what the frequency is?
It's 25 megahertz.
Usually, yes. Usually,
Yeah.
25.
So it's not that hard to get a good 25 megahertz GPSO lock that you can then clip the crystal out and inject.
Yeah, yeah.
That's our friend in England that makes those.
You can also read the 25 megahertz back on the second coax and figure out what the output LO frequency is doing. I've done that.
But he's multiplying this up into the gigahertz, right? Aren't you, Edward? What is your final reference oscillator at?
The LO is at 10.7 gigahertz.
Yeah. So there, if you have small error, it really gets multiplied up.
Yeah, you've got to be reading it down to the hertz. I've been doing that. I've got one on the roof right now.
That sure sounds like the quick and dirtiest way to do it.
You're talking about using a Leo Bogner reference, is that right? Is that who you were referring to?
That's my go-to box when I want something simple, yes.
I don't know if you're familiar with those, Edward, but they're around $120 US. And they
I have one.
Yeah.
I have one. I use that for 22 gigahertz for my reference.
Okay.
So I just wanted to test, like, could you do this type of observation without any reference signal or any need to open up and actually do a lot of soldering in the LNB, or it just was a fun experiment.
Yeah, the difficult thing is that you had to multiply it so far and you're running for 3 hours, I think you said, for integration time. So it's got to stay stable for 3 hours. So.
Yeah, actually, yeah. I was pretty pleased actually by the result, because you can see really that the sides of the spectral line are really steep, so it's not smeared out.
What is the peak? You have another peak over to the left of your signal also. Do you know what was generating that?
I think that's just an RFI.
Okay.
A frequency stable RFI?
Apparently. Yeah. You do get quite a serious amount of intermittent RFI at this frequency because of all the satellites.
The Leo Bodner injection for the crystal is really the cleanest solution.
Yeah.
Okay. Anything else for Edward? All right. Thanks very much. And if you get any good, guys, if you get any good optical pictures, we'll take some optical pictures during the forum. Don't shy away. We're not too worried about it.
And Dennis has a question. Dennis Hoffengale.
Hey, go Dennis.
Edward, how are you tracking for a 3-hour integration?
Actually, yeah, this is where my optical astronomy stuff comes in, because I'm using a HEQ5 equatorial mount, which I normally use for astrophotography. I just placed my dish on the mount.
Yes. Okay. Yep. I expect to do that also. Thank you.
Okay. And Dennis, since we got you on, what are you doing lately?
Well, I'm clear back to basics. I was going to put up a mast to put my my Wi-Fi antenna up there, and then I wanted to ground it because I thought, well, lightning is always possible. And then I discovered that by code I should bond all of my grounding rods And so I'm in the process of putting in 2 new ones and running a number 6 wire all around the whole works, continuous. So how basic can you get? Sorry. Hey, I had one question too, although. So with the attenuation with temperature and cabling, I'm sure people have experimented with fiber optic, which I would think would be less affected. But even beyond that, what about RF link? And you just completely eliminate the conductive cable entirely. Even, even using small microwave or something, seems like that would be something that would have the potential to eliminate the temperature issue in your cabling.
Well, I guess the trouble that you're running in with an RF link is, first of all, RFI, because you have spurious emissions from those. Second thing is phase stability. I doubt that there is a sufficient phase stability on an RF link.
Okay.
And finally, one area of concern also in a polluted environment, say where you have a lot of RFI, is dynamic range, which is also affecting RF over fiber. You always, RF over fiber is fine. Certainly a good solution for a number of things, even especially if you have to cover longer distances. But typically the dynamic range is an issue. I'm hoping to have some equipment maybe later next year, RF over fiber, where we can do some testing. But yeah, we don't have that. We're just using what we have. We have lots of long coax cable, which we're trying to make good use of.
Sure. Thank you.
That's it, Rich. Thanks, Dennis. Well, Dennis brings up a good point. What's everybody else using for grounding on their antennas? He sounds like his is not overkill, but different, more than I've seen anybody else use. Anybody else like Alex? What do you put down for your antennas for grounding?
Well, not for this. I mean, mine are all portable. For my HF frequency, I have a ground, but I've taken out two of those lightning arresters. It all depends on the proximity of the lightning. When it's within a few hundred feet, it doesn't matter. And so what I do for my ham radio is my coax, the coax coming into the house is always disconnected from everything. I just keep physical space separation. That's and there's lots of lightning. Orlando's like one of the lightning capitals of the world. I just don't connect anything to the outside. Grounding might keep your antenna from melting. It's not going to protect you from a surge inside the house.
Yeah, Rich, on mine, I have of course a ground rod at the antenna, but everything comes into the house over fiber, so I don't have that direct problem from the standpoint of coax. But yeah, it's just there's a big ground rod at the base of the concrete mount that my 4-inch pipe that goes up to the 3 meter, and that's that whole thing is pipe, and everything is grounded through that ground rod.
Okay. I'm Rich. I don't know too much about grounding when it comes to radio, but I do know my mum actually had her house hit by lightning while she was using her computer, and it took out anything electrical, electronic that was connected to it, shifted the chimney by a foot or two to one side, and ended up with a surprisingly large amount of work required afterwards.
Yep, same thing to my house 3 years ago.
A well-grounded 30-meter dish over the house will protect the house.
That's a good idea. Can I ask what probably is a very simple question? I've never thought of it before. We were talking about grounding. Obviously, I'm doing very small level stuff compared to what people have been talking about. So sort of aerials or dishes in the sort of 1 meter class. Do they need to be grounded to work more effectively?
Negative.
Negative, okay.
Okay. So grounding is really just for the lightning protection, it looks like, or if you're ham radio, obviously you got to ground on those.
Ham radio does not need the spikes in the ground either to work.
No.
Okay.
A very common fallacy.
But within the U.S., the code is that your service panel has to have a ground, and that establishes the ground. And now it used to be you had a single ground rod at your service panel. Now I think you have to have a second one 6 to 8 feet away.
Yeah.
And those have to be bonded together continuously. So yeah. So I have a single one at the service. I'm adding another one 9 feet away, and then another one at the corner of the building where I'm coming around to a ground that I already have for my mast. But anyway, I'm making that turn. I'm going to put a ground in there also. So I get really kind of anal about this stuff, and I'm I throw salt and charcoal and benite into the hole that the ground rod's in, and try to sweeten it up for conductivity all I can. And we'll see. We did experience I wasn't here, but my family, there was a place about 150 yards away that got hit by lightning. And I talked to those people, and it hit the chimney and blew bricks down into their hot tub and everything. But about 30 seconds afterward, my family, my wife and son and a neighbor kid are sitting in the living room, and a ball lightning floats through the living room and disappears. I wish I'd seen that. But anyway, and I flew as a radioman in the Navy, and we had a couple lightning strikes, and people said ball lightning came out of my radio equipment, bounced down the aisle, and went off into a radar console. And I didn't see any of those personally. I wish I had. I still think the origin of ball lightning is totally ununderstood, not understood.
I mean,
All right. Well, when I was the electrical officer on a sub, one of my electricians pulled a fuse out of a running 400 kilohertz generator and experienced a ball lightning.
Oh, wow.
And that was not fun. But after I asked him how if he was okay, he said yes, and then I started yelling at him. But anyway, okay, Alex.
Let me mention on the lightning rods, you said something important, I think, and that's when you put the two rods down that were bonded together, and if you put in more rods and you can get between them, you need to bond them all together, because you can set up paths for ground for lightning or whatever if you don't keep them all tied together.
Absolutely.
Yeah.
You've got to avoid ground loops because you're running currents up to 30 kiloamperes peak with some lightning discharges. So even a 0.001 ohm difference can give you a considerable current flow.
You're not going to ground 30 kiloamps. It lifts the it lifts the earth. I mean, you just sit back and figure out what to start ordering new electronic equipment. So that's it. I do have a small presentation, and it's a problem. It's Andrew's problem, and I'm not sure what's going on here. I want to share a few slides. Let's see. This guy. Are we there?
Yep.
Okay. This is This is kind of characteristic of what I get with my antennas. It's not particularly high. It's about 1.2 dB over cold sky. And this is with the YAGIs. I ship one of my disc YAGIs over to Andrew, and he's having some pretty poor performance. So anyhow, I had him send me some data, and he did a couple 24-hour drift scan. Now, take a look at this. The bottom is on the same scale. Oops, hold on. How come? There we go. This is one 24-hour period, and this is another 24-hour period. There's nothing there. I'm getting about 1.2 dB. This is like a tenth of a dB with the same antenna. So this is expanded up. So it's like, 0.15 or something. Really incredibly low amplitude. So this is a comparison. This is what should be getting about 1.3, 1.4 dB over cold, and the data I got from him shows something like this. So I had him run some tests. Disconnect the antenna. In both these cases, we're using Sawbird LNAs. I had him disconnect the antennas, feed in and to record the background levels with the LNA open and with a 50 ohm load. He got 3.5 dB differential, I got 4.5. So it says the electronics is functioning. I don't know why they're different, but it says there is a change. So the electronics from the LNA input back through the SDR is working. But here's where it gets really crazy. Had him point the antenna towards the sky, and he sent me the data, so I made the measurements. Between pointing at the cold sky and pointing at the Earth, I get about 5.5 dB difference. He got a 0.5 dB difference.
A question.
Yes?
What difference do you see at the SDR when you turn the LNA power off and on?
I don't know. I mean,
that's the key to what you're looking at is, I suspect, starting there.
Well, I've done a lot of tests. I mean, it's the SDR. This is showing this one. Whoops. This is showing that the LNA is functioning because I get a signal all the way through. For whatever it means, we get about 4 dB difference between an open and a 50 ohm load on the LNA input. So it says the rest of the downstream stuff has some functioning. The antenna has a big difference. The antenna is built correctly. It's the feed point is correctly oriented. The only thing I see that is discrepant is this little solder joint that's supposed to be made between the circular patch feed and the SMA connector looks wacky. I mean, 10 to 1 is ridiculous.
The measurement I'm suggested takes the antenna out of the test equation, essentially.
I did that.
The question is, how does the SDR's noise floor change when the LNA is turned off and on? And that goes to whether you're not driving the SDR correctly at one of the two sites.
Not driving the SDR correctly. I don't understand that statement because in both cases the LNA is connected to SDRs, different kinds, but
you have the ability with the software controlling the receiver to turn the bias for the LNA off and on, do you not?
He may, I don't, because I use an AirSpy. You want it powered up and not powered up? Did I lose?
I think I sent you that data, didn't I? Alex,
I don't.
I sent you with the
There was a
power
lot
on
of
or power
data.
off. I'm sure I did.
Oh, I didn't know that was on purpose. I thought that was accidental.
No, I didn't know what I was doing, so I just did put down everything and then tried to do all the
Oh,
options.
I thought the way you stated, I thought for some reason it was accidentally not connected or something. Okay, anyhow, I'll take a look at that. But the only thing I see here is that there is some functionality of the electronic system. The antenna is dead, and physically it looks fine, except for this. Still, you really need to resolder this and see what happens. I mean, I'm baffled.
I would suggest you make the measurement, and he does, of turning the LNA bias off and on. You should see at the SDR at least somewhere in the order of 15 dB delta in noise floor with the LNA off and on. If you don't, particularly at the UK end, I think we can point the finger, but you need to make that parallel measurement.
Andrew, do you have that data? I mean, mine works. I mean, do you have that data?
Well, I'm just trying. I think I've got it here. I might be able to just share it.
That's what I'm saying. Let me go stop sharing this screen. He may have it. I mean, it'd be easier if he has it than me to try to dig back through the dozen or two emails that we exchanged.
Right. Have you got this? Is this turned up? Tests on the Farmigan AP21 YAGI? Has that appeared?
We see
no.
it.
Yes. Yeah,
you can't see it. Hang on. Share it.
Yes, we see
Your screen sharing, it says on mine.
We see it.
See it. Okay. So so we got their bias T off at -55, and above it we've got bias T on, and that's at just between -25 and -30.
Say those numbers again. Repeat those numbers because I can't read them.
All right.
What is
so this graph here at the moment, the bias T is on, and that's minus on the left. Well, the actual sort of pretty much the flat line there is about sort of -27, something like that.
Yeah. Okay.
Across, and then here, this graph here, I've switched the bias T off for comparison, and we're sitting at -55.
Okay, so that's good. Okay, so unless that answers your question.
Is there an impedance mismatch because he's using a different SDR than you are?
Won't be that long then, I'll come in.
Using the exceptional one, because most people just use the no electrics or the standard RTL SDR. I'm using but I mean, no, there's no reason that the system should not be performing. I mean, it looks like there's a defect in the antenna. The only thing I can think of is take it apart, clean that solder joint off, and replace it. It might be, you may have had the perfect rosin sleeve around that center pin that you could never duplicate a million years. And it may be that, I mean, that's what it looks like. I mean, it just looks like nothing's coming through the antenna. And yet, physically, you can't build it that poorly. So it's got to be something very dramatic.
Oh, Alex, sorry, Alex,
another.
Sorry, forgive me. I was going to say, if there's anybody who is capable of doing that, it's going to be me. I have a history of achieving that type of thing. Sorry, Wolfgang.
Yeah, another thing that might have happened is that in your area, Andrew, you have a fairly strong signal out of band, which saturates your receiving system. That's another option. That I've seen that many times, that in cases where you have a strong interferer, which can be out of band, so you don't see it in the spectrum right away, but it saturates your receiver and you lose sensitivity because of that. One way of checking that is if you have that available, look with a spectrum analyzer, either right at the antenna or after the LNA. Yeah, that's one other option. Of course, what Alex was pointing out, the solder joint that can be easily checked. Of course, the antenna functionality could be checked if you have a network analyzer, which you probably don't have. But anyway, I wouldn't take out-of-band interferer into consideration.
Andrew, what's the chance you could move that to like a mile or two away to a local park or a school or a church parking lot, just to see if you get the same answer? All you need to do is just do the cold sky, the earth. Just point it overhead and point it 45 degrees down.
I could take it, our next astronomy meeting, I could take it up to our dark sky site with me in a couple of weeks.
Yeah, or like I said, just any change in location, just to verify Wolfgang's thoughts.
Yeah, I'll do just that.
And the other thing would be, I sent you some contacts for ham radio guys. If there's any ham radio guys that do satellite communication, they're familiar with the UHF microwave kind of stuff, and they might be able to take a look at your system. But honestly, I would take that apart, change the solder joint, just do the earth and sky. That's all you need to do. Just do the SDR sharp and earth and sky. You should get, if you get 4.5, 5 dB, you're home.
I'll do that. Thank you, guys. Thank you very much.
As something I have heard of, and is silly enough that I would have easily have done this without noticing, realize that there are two different types of SMA connectors, SMA and SMA reversed. And if the connector you have on your antenna is the reversed and everything else is normal, you don't have a connection between the cable and the antenna. So that's something I'm sure of. One of them has got to have a pin and the other one's got to have the socket.
I supplied that. Hopefully that has a pin in it.
Just saying. That's
well,
something.
You're right. I mean, I buy them.
Sold it to something.
I buy a box of them, and it's, yeah, I mean, that's worth making sure there's a connection there. You're right. Yep. Should take a look at that connector and see if it has a pin in it.
Yeah, just to say, I did solder it, and well, probably soldered it badly maybe, but there was definitely a pin I soldered to. And secondly, that particular mistake I made very early on in my radio astronomy journey, so I'll never make it again.
Could the LNA input and output be switched?
No, because I double check it.
Because the open and the resistor work. See, that tests everything else. Putting an open and the 50 ohm on the antenna side of the LNA checks everything else. Says everything else works.
Yeah, the fact that that delta with the LNA off on shows that it's good.
All right, great troubleshooting. Let's see if we anybody else got anything real quick. Alex, you got anything else? Great mystery.
Yeah, I just wanted to show you one other. This is just an overview of this do-it-yourself YAGI project. Looks like that. This is coming along. This is pretty much underway. I don't know if you can see that or not. Anyhow, this is I've been working on this since before Christmas. This YAGI, 21 centimeter YAGI, and I have it developed, and I've shipped a few, Andrew being one of the victims, but there's another version of this that I've been working on, and it has its own little issues, but this is a do-it-yourself, typically a high school science project level, and it uses a wooden dowel, lower, thinner aluminum material, and it's stuff that can be built with only hand tools. The only power tool you need is an electric drill. And so this is coming along. It had its own quirks, and I have this running as good as the more sophisticated, exotic version. So this is going to be, the information on this is going to be turned loose soon to the world. And I think this will make some, hopefully get some interest up of young people getting involved and doing it yourself.
A question?
Yes.
Did I read correctly that there were some negative effects of using the threaded rod down the center?
Muted, Alex.
Whoops, wait. It's a really big deal. What I've developed here, you can mount this properly on a $25 camera tripod. The 3/8 threaded rod, that whole system weighs about 4 pounds, and you can't. It'll knock over the rod. And so, yeah, that alone is prohibitive. It's also like $20 as compared to $2. And so it is just, it makes it much more ruggedized. The one that Andrew has and the few that I've shipped, all of the aluminum discs are 16th inch, I don't know, 2 millimeter or something, whatever that is equivalent, 3 millimeter thick, aluminum, and it's rugged. This one is kind of frail, but it will certainly be ideal for a few night out events for science project. And that's the only difference. This winds up being nice and lightweight.
I understand, but there was no electrical, as opposed to mechanical, there was no electrical reason not to use a threaded rod.
No, and there's a huge advantage in that you can apply sufficient pressure that you have very good electrical continuity across all the elements, and that's important. I had to add a few changes to this wooden dowel rod to accommodate for the lack of pressure. But yes, no, tensioning the rod. In fact, tensioning that rod, it makes it what you do is you put all of the sleeves into compression, and it's amazing. That antenna with the rod itself is very flexible. You put on 3/4 of a turn of torque, and that thing becomes very rigid because you load up the aluminum sleeve spacers.
Excellent, because somehow I'd gotten that there was an electrical issue, and that just didn't make sense to me. So now that I got the chief toad in front of me, I asked the question.
Okay.
Thanks, Alex. There's a Zivco, ZHIVKO online. I think you're new.
Hello, guys. Can you hear me?
Yeah, go ahead.
I'm new in the society. I have interest in the topic, nothing that I have built anyway. I have built yet. I'm just gathering the inspiration, information, and so on. The topics are really interesting. I'm ham radio operator. My call sign is Lima Zulu 8 Delta X-ray, and thank you that I'm part of this conversation. It's very informative and very interesting to me.
Great, thank you. Have you got a radio astronomy? Where are you located, and do you have an antenna, or you start a project?
Not yet, but I'm considering to do that. Maybe my first project will be the one. Sorry, I forgot the name. That one that listen to the frequencies transmitted by the submarine communications.
That's a SuperSID program.
SuperSID, exactly.
Yep. Okay. Well, great. Well, you know where to find us. So just get on these and get on the link serve, and a lot of SuperSID users there that can help you out if you want to. Okay. Thank you. And let's see.
Thank you very
Jack.
much.
Oh, go ahead.
Just saying thank you. Thank you.
Okay, no problem. Jack Lobinger.
Yeah. Well, I haven't been doing too many new projects from the standpoint of observing. I'm still pretty continuously observing hydrogen. with the 3 meter, and kind of interested in some of these emissions from these supernovas. If we get any really big ones close, at what might pop out there. But the other thing that I'm doing and have been doing for quite some time now is different motor combinations, if you will, for the altitude azimuth mount positioning systems. The information that I published in the journal is just using regular DC motors, geared motors with optical encoder feedback. But I've also developed a servo motor equivalent, and more recently here a closed loop stepper motor drive. All of those being absolute position kind of things, and these are, 300-400 watt type drives. So
I just happened to have been exploring a stepper motor gear reduction.
Yep.
You can see that.
Yep.
I don't have the mechanical engineering skills to take it much further, but I love stepper motors for their reproducibility in my CNC.
Well, there's a sort of an indication of what some of this looks like, but these are usually NEMA 33, 34 size motors, and controllers. The servo controllers. There's a servo controller, a solo servo controller out of Italy that is a really fine little controller for servo motors, and I'm using more or less standard parts for the stepper motor, closed loop stepper motor controllers, although they're internally sort of servo as well. But anyway, they both seem to be doing quite well, and accuracy really far beyond anything that we generally need in radio astronomy, at least with the size stuff that we have, unless you get up into some of the guys with 30 and 40 meter dishes. But anyway, it's been kind of an interesting thing, and doing the Python programming to support all that. So anyhow, the programming looks somewhat like the programming that it was in the journal when I published the DC motor drive. That's pretty much the same kind of interface, but the drive technology is either servo or closed loop stepper motor. So anyhow, just exploring those, because I'm a lot better with mechanical stuff than I am with math. So anyway, that's just what I've been doing.
Okay, thanks, Jack. Any other questions for him? Okay, thanks. Charles.
Yeah, I've had a couple of things that are related to what we're talking about. I've actually been down for a few weeks with problems on the dish caused by an EMP hit nearby. Took out a few things in the cable system, and so it took out my dish elevation readout. And I had been worried about that enough that I already had ordered something to investigate, but naturally I kept putting it off, and so I didn't have it ready when the event happened. So lightning struck before I had tested it out. But I've got these little 3-axis type accelerometer things that are supposed to do real, 0.01 degree or some kind of accuracy that seems more than good enough for what I'm doing. So I've got to get that software working. The older unit that I've been running for 10 years, well, of course, was on Windows XP or before. And so I couldn't get the software to run on even Windows 7. So that was also presenting a problem. And this new thing is coming at it from the other direction. It's new enough that doesn't want to work on Windows 7 because of .NET version incompatibilities and things. And so I'm dealing with that. But yeah, I'll give you an update when I figure out what's going on with that. Talking about grounding, I was in an interesting position, I guess, building a new house. My rule was if I had a ditch open, put copper in it. So I don't think that it's nearly impossible to get too much ground. So when I had the foundation open around the house here, I had some old 7/8 Heliax that was damaged, had water damage inside. So I stripped the jacket off of that and took the copper and ran it around the house. As it stands, my 67-foot ham tower's on one end of the house and the service entrance panel is on the other. So I wanted to get a good ground field. So all the drains for the gutter drains, those ditches have number 6 in them while they were open and then closed up. Multiple ground rods so that it would meet the inspector's desire for that. But that was trivial compared to what I wanted ground-wise to ground the tower. So yeah, I've got the house completely ringed with basically 3/4 inch copper pipe as the ground, and then going out from there in other ditches, like to the septic tank and other places. Number 6 basically had some of that ready anytime I could. So there's 500 feet of ground wire around the house, all connected together to add to the ground field. And of course, it's a connection all the way over to the panels and then even inside the house, because there's a breaker panel in the dead center of the basement. And so I was kind of worried that would be not, it's 25 feet from the service entrance panel. So I added some ground there too, as far as going back to some of these other ground points. Let's see something more related to what Andrew was talking about. I also had a problem, naturally, due to the lightning storms or the rain that comes with them. I've had 3 good years of running the dish and everything being nice and stable. And the recent hurricane that went through in August dumped like 6 or 7 inches of rain. And all of a sudden, the hydrogen line signals started getting not as stable as they were. And so at some point, it finally got bad enough that I was getting 5 dB of change, just kind of unpredictable. And what that turned out to be was enough moisture got into one of the type N connectors that it started growing connection between center pin and ground, because naturally we're running voltage on the center conductor a lot of times. And so you'll find there's some migration of metal if you get enough moisture in there. So even before you find that there's some loss, it starts growing green corrosion across the Teflon. And so eventually that got bad enough that I could find it. I was afraid it was going to be in the underground conduit. I just figured water got in the conduit and the coax is sitting there underwater basically, and that it got into the coax. But it turned out, fortunate for me, that it was out at the dish where I had a 10-foot jumper up to the LNA. And so I took that actually took it loose from the LNA and used a time domain reflectometer to to see where that short was, and I could see it on that. And so I took that last piece of coax out, and the problem, when I replaced it, the problem disappeared. So now I'm back to nice stable measurements. But that loss after the LNA, but before the underground coax actually caused 5 dB of loss, and it was kind of unpredictable since it's voltage related. So that's something, a lesson that I think a lot of people could learn. If you got something outside with voltage on the contacts, it will grow the corrosion across the insulation. So that's the fun that I've had lately. So yeah, I'm down trying to get my position readout going, and I've got the hydrogen line working, but I'm not as able to move the dish from inside. I can go out there with a digital level or something and manually set it, but if it's raining or something, that's not nearly as convenient. Okay, that's all I've got, Rich.
Okay, great, Charles. Thanks. Jameson Adcock.
Hey, how's it going? Let's see. I've mentioned before I've been working with Alex on putting together a Java program that will slurp in IF average data and put out a nice corrected and scaled dB comma separated value file. Haven't made tremendous progress in the last month because school started, the kids are back, and our normal level of chaos has been unusually chaotic. One thing I did get to do is this past Friday, there was an event in downtown Washington, D.C., which is pretty close to where I live, called Eisenhower Under the Stars. It was sort of a celebration of the president who got us into the space race. And there were a number of astronomy clubs invited, including the one that I belong to. And so I brought my radio dish and gave some public demonstrations of picking up the hydrogen line. And I met some folks from the Air and Space Museum who bought, you're nodding your head, so I think they mentioned that they'd been in touch with you. And they asked if I could help them because I guess they've had some trouble getting their dish to work, or they don't quite know what to do with it. So maybe I could speak with you offline as to, what you've talked with them about. I've been sort of dealing with them indirectly, actually, through a coworker. And I finally met one of the people face to face last Friday and said, well, sure, I can do a Zoom and see what I can do to help you out. So
excellent, because and I was going to mention that, but I'm glad you brought it up. Air and Space Museum contacted us, and in fact, they bought a scope in the box. And then we just sent them, Ted and I got on the line with them, and they're very good. They've been demonstrating stuff. So we're going to start getting them the hydrogen stuff worked out, and the ability to use like the EZRA. And then we just sent them a itty bitty telescope with the mods that Tom Crowley puts in, so they can actually take that directly into a mic input and use radio sky pipe to show the output on a digital graph, as opposed to just listening to the tone on the satellite finder. So we just sent them that, so I'm very glad you're in the area there, Jameson, because we are trying to figure out a way to get one of us to go support them, giving demonstrations and figuring out how to put this together. So
I'm happy to do that because it's just down the road. I think you're out in Green Bank, which is about 4 hours away, right?
Oh, I'm in Colorado Springs,
you're in Colorado. Okay.
Yeah. So if you're close, then that's great. I'll put you on the email list, and they just got the IBT like a week ago. We sent them a free one, and they're going to go advertise Sarah. Air and Space Museum, Smithsonian has one of our scope in the boxes and one of our itty bitty telescope kits. All right, and they're demonstrating that. So I thought that was really cool, and now they just need to. All the brainiacs there just need to figure out how to use it. And so I gave them all the links, and Ted talked to them, and So hopefully, if Jameson with an online, a local support staff there, we can really get them up to speed. And
that's great. That's excellent.
Yeah, I'm happy to do that. As I said, it's not that far to get down to DC.
And
I
that's
could
always
bike down there, but
it always creates a personal learning curve too. You
yeah,
find
well,
out what you don't know.
I think sometimes like just having somebody there in person, because they wanted to do a Zoom, and I was like, well, if that doesn't work out, I can come down, and I showed them, for example, I had SDR Sharp with the IF average plugin going, and gave them sort of a quick overview of what I was doing. I spoke continuously for 2.5 hours. We had quite a crowd, and a lot of people were like, "What is this dish?" So it was a lot of fun.
You have the software package that we give with the scope in the box?
Me, I don't. I just
That's
I got started using the cheap and easy hydrogen line thing, and I just ran with that.
Your call is displayed as KC3YM, is that correct?
KC3YMJ.
It's the J I missed. You wouldn't come up on Google. Gotcha. I'll send you the package. It's got some hints and kinks.
Okay, thanks.
Okay, and we talked about using EasyRA too. It seems that the problem the Air and Space Museum has is that they have to use government computers, and any new piece of software they put on, they have to get verified that it isn't a virus. So they are really hampered with new computers. We were talking to them about getting some Pies to use, and maybe use the EasyRA on Pies. So, but there's a great conversation we're having with them, and so Jameson, I think you're local, then we can we'll support you as our technical technician staff, and hook up with Ted and myself, and we'll get you all the support you need.
Okay, appreciate it. And then I guess next month, Alex and I'm sorry, Alex, I've been the holdup, but we'll have some slides and talk more about the Java program. So so
maybe we'll do a Zoom in a couple of weeks and try to get all the pieces together. What Jameson is talking about is what I want to try to do is to put together a combined presentation with my build-it-yourself YAGI and his software, which takes the SDR Sharp to IF average to this CSV files, which are readable by this Rhinian 3D software, that we have some common place where everything is one spot, is a go-to. Like I said, the intent is just to get younger people involved and to simplify everything, where you can build your own antenna, and here's the software to create some really easy graphs all in one package.
And I want to make a recommendation here that Alex, when you get this figured out, if we can pay for one of your antenna kits that we can send to the Smithsonian staff, and Jameson can help them put it together, and they can use that for their hydrogen measurement. This looks cool. They'd love to demonstrate that, I'm pretty sure.
I will, no problem. I'll donate one. In fact, I've got some pieces left over. I'll give them the discs. The recent ones that I have been selling, if you will, basically at cost, have the rectangular plates, because they're an awful lot easier to fabricate than turning discs on the lathe. But I'll give them one of the original. I'll give them one of the original ones, in that way they can see physically the outside of that, except for it being beefy or aluminum, is identical to the do-it-yourself versions of and so that would be really good. That'll be a durable one that will survive lots of hands-on touching, and then this can be a model that. There's small variations, but this can be a model if they want to do the do-it-yourself kit that I have designed. So yeah, that'll work.
Okay, and realize that they, I think they're limited on the ability. They can buy stuff, but they're limited on the ability. They were having trouble with the original scope in the box, that they didn't have the tripod legs. I mean, and they couldn't figure out what to do with it, right? So Jameson, that's the kind of thing where if they need whatever, Alex's setup's really cool with whatever he uses for his legs. that's
Yeah, so let
something
me
that
see.
if you see something, we can get them that, or we can find one for them. Because I think they're really limited on the ability to come up with that themselves. And I know it's Smithsonian, but they're into the observing, not the building, I think.
Yeah. I think just a little hand holding and like they were
I
looking
think,
at what I had, and I basically had an old Japanese aluminum tripod, and I bolted on the Wi-Fi extender dish, and it looks cool. They got a lot of
okay.
comments just on like how it looked, so I'll
All right.
happily help them out.
And I
So
think what
that's it
would
for me.
happen, they would end up putting this stuff on display somehow. And if you had a placard with each one of them that somebody could shoot a picture of with their cell phone, that has a link on it that gets them back to us.
Well, there's a problem that they are not allowed to advertise us.
Well, just the instructions on how to build one, like
I
Alex
know,
was
I
saying
know.
earlier.
It's but if they use all our literature and things like that, and so there was we even asked them that, and they said, well, we're not allowed to do advertisement for any individual group, but they are going to go mention us as the suppliers and stuff. I mean, they're going to do that, basic stuff, but they can't like put a Big Sarah sign up and stuff. So anyway, we'll work on that. And Jameson will wear them down and put some logo. We'll get some stuff to you, Jameson, for swag.
Rich, this is Dennis.
Yeah, go Dennis.
I wonder if you could include me on conversations or communications that are going on with that. I would appreciate it.
Oh, that'd be fun. No problem. You haven't talked to him in a couple of weeks, and so maybe we need to have a sort of a group meeting before we talk to him again and sort of coordinate a little bit. But right now they've got the IBT kit, and I haven't heard anything since they've got it, which was about 2 weeks ago. Anyway, okay, let's go on to Dennis. Dennis Farr. Now that I've got you on, welcome back, and you've regained your board membership, and what else you got going on?
Not a lot. I'm partially disabled now, so don't get to get out, but I follow all the email lists. And of course, anytime I hear the term scope in a box, my heart swells because I have some background in that. But other than that, I'm just currently an observer and trying to add whatever experience I can offer.
Yeah, for full disclosure, Dennis really started the Scope in the Box project. It's his baby, I guess.
And now it's at the Smithsonian. So who figures there, Dennis?
My whole family is waiting for some kind of acknowledgement or pictures or something that of how it's being used. So I'm most anxious to hear what it is they're doing and how they're doing it.
Yeah, it's the Air and Space Museum. They're giving demonstrations with it, and I don't know the extent yet. I think they're still in the front end of that, but it should be picking up. Now we got Jameson local there. I think he can really jumpstart them a little better. Okay, great. Thanks, Dennis. Glad to have you back. And Ed Harfmann.
Well, I haven't gotten any observing done, but I got out last weekend and the weekend before giving a couple of presentations. Basically, a general presentation introducing radio astronomy, why we do it, how we do it, and some of the various things that we've discovered because of it. And both presentations were very well received. So that was a good thing for me.
Great.
That's it.
And Ed's famous for the intro to radio astronomy that's on our YouTube site. And that's the first thing that the new user hits that's the first video they get.
My condolences to all who view it.
So he's a YouTube star. Don Latham.
Nothing to report at this point. I did get interested though in the solar cooker dishes. So I ordered 2 of them. So I'll see what I can do by way of
measuring them up and see about a feed.
Yeah, it's
that's an absolutely incredible buy. If we can get a 4-foot dish with some kind of adjusting mechanism for declination that's already built onto it with a, it's got a swivel jack on it of some kind, that would be absolutely incredible. Cost effective as heck. I mean, face it.
Yeah, and having melted my feed with the 18-meter dish in Haswell a couple times, just be careful of that.
Absolutely, no question about it.
Okay, I think, does anybody I haven't got online yet? Okay, anybody else have anything else?
Preston?
Oh, Preston, I forgot. Yeah.
Well, it's okay because I don't really have anything, so
that's okay.
Balance that fine.
All right.
One thing, Rich, just to throw this in, my brother gave me something for my birthday that there's this Great Courses. You can't see it very well, but this is Great Courses course on radio astronomy by Felix Lockman out of Green Bank, and it's a several CD set on radio astronomy. It's probably something that a lot of you guys have already seen, but I've been going through it, and it's about a 3 or 4 CD set on it with a guidebook and all that. It's pretty good overview of radio astronomy for anybody that is interested to check out it, the Great Courses site and take a look at it.
Okay, and a little background on that is that Chip, our webmaster, is good friends with Felix and got us a good deal, Sarah a good deal. So if you're going to get that, contact us first. And there's a great deal for Sarah members to get a very cheap thing of that. We also, Dr. Lockman is now a emeritus, or not emeritus, an honorary member of Sarah. And he is also planning on using us potentially to produce some videos, because he likes our YouTube channel, and we might be producing some videos that he's going to do, especially on SETI work. So we're really engaged with him right now, and but yeah, if you're going to get one of those great courses for radio astronomy, talk to us first. You get a real cheap. I mean, it's extremely cheap. You got Chip got a really good deal on it.
Of course, he was the speaker. He was the speaker at the August conference.
Right, and it's yeah. If you want to see his, he had a great talk on a YouTube channel with that. Okay. All right, that's it. See everybody now. This Friday is the Drake's Lounge Australia. So that's at 9 a.m. Melbourne time on Saturday UTC, or Saturday Melbourne time, which is about 5 or between 5 and 7, depending on Eastern time on Friday night for US. Okay, and so I'll see you there. And yeah, go ahead, Alex.
One more. I just wanted to show you the picture. This is what I'll be sending probably to Jameson, and then he can set it up over at the museum. So this is what the antenna looks like. This is actually the home-built one, but it'll look the same. Looks like a nice ray gun. And I thought I'd include this tuning chart. This is kind of luck, but this is right on 1420, minus 64 dB return loss. So these look kind of cool because they look like a space gun. So
I think they're going to love to demonstrate that. I think if they get hydrogen signal out of that, they're going to love it.
Yeah, that's what I'm hoping.
Is this the one with the wooden dowel or the?
This is with the wooden dowel. Yeah, you can't tell it from the outside.
I have the one that you sent me the parts for that I built. That's got the threaded rod.
Yes, you don't have the sleeve.
It does look cool.
Yeah, it does. So I will, well, I'll send you another kit of this with the sleeves, and all you need to do is to buy the center 3/8 rod, and then we'll have to figure out how to mount it on some kind of a tripod. But yeah, these things look pretty neat.
Alex,
And I think,
before you go, on that picture, what on each disc there's a little radius coming off? What is that?
yeah,
reflection?
that's a little loop of wire. That's the secret sauce.
Cool. All right.
This thing, that's what I'm saying. Even what you do is you actually thread the dowel with the nut, with the 3/8 16 nut. So you have something against which to thread, but it's not tight enough. And cutting the sleeves by hand gives you small discontinuity. So it's in the instruction manual, soon to be published, but this provides continuity, and it has the same response as does the one which compresses with the steel backbone.
Nice. Okay. That it, everybody? All right. Talk to you at Drake's Lounge, Australia, or the Art Top on the 1st of November. Excuse me, September, October. Yeah, October. Okay, see you later.
Okay, bye.